All right, we're going to do a lesson on angles. We're going to start with naming and classifying a single angle, and then we're going to talk about pairs of angles. All right, so the first thing we're going to do is talk about opposite rays, and defined opposite rays as two rays, ray BA and ray BC, such that B is between. Between A and C. Okay, so opposite rays, point B is collinear with A and C, and B is between them. An angle is formed by two non-collinear rays with a common endpoint. The rays are called sides, and the common endpoint is called a vertex. So let's name the sides here. The sides of this angle are ray OA and ray OB. The vertex is a point, uppercase letter. And we can name this ray this angle four different ways. We can name this angle AOB with O the vertex in the middle, angle BOA with O the vertex in the middle, angle O, and angle 1. This is a very common way of naming angles on SATs and standardized tests. The way we cannot name this angle is OAB. We couldn't put one of these points in the middle. The vertex always goes in the center. Okay, so down here we have a practice problem. It says, name the vertex of angle 4. So you find this angle here, and the vertex, of course, is a point, U. Name the sides of angle 3. Here's angle 3. And the sides are XW, ray XW, and ray XU. Always starting with the vertex. What is another name for angle 2? Angle X, Y, U, or angle U, Y, X. A bad name for angle 2 would just be angle Y, because we wouldn't know if you were talking about this Y, this Y, this Y, or that Y. So we couldn't use just the vertex for this angle. What is another name for angle U, X, Y? U, X, Y, remember the vertex is in the middle, so this is the angle here, angle 1. Good. This is a very, very important warning. Do not name an angle O when there's more than one angle next to another one. There are 3 different angle O's. There's this angle O, there's this angle O, and there's this whole angle O. So by calling this angle O, I would just have to mark that wrong on a test if that was the answer to a question. You could not call this angle O. I wouldn't know which one you were talking about. Okay, an angle separates the plane into 3 regions. An angle is a plane figure. It exists in a plane. Polygons are plane figures. They also separate the plane into 3 regions, so this concept will be used to describe other things as well, not just how angles affect the plane. Okay, if I asked you to shade and I wanted to describe where I wanted you to shade, I might say, oh, shade inside the angle. We call this not the inside, but the interior. It's this whole shaded region. If this is the interior, this region out here is called the exterior. And the third part is called the angle itself. These are the 3 regions. Okay, and I might ask you, oh, place point R, in the interior. And so somebody would do this, draw a point and label it R. Place point B in the exterior, somebody might do this. And here's point B in the exterior of this angle. What if I placed a point here? Let's call it, W. Is W in the interior or the exterior? Well, we have to remember, these rays are infinitely long. Of course, we have to stop at some point when we're drawing them, but they are infinitely long, infinitely long. And this should actually be shaded as well, but of course the computer only shades and leaves some margin kind of work. So W is in fact in the interior of the angle. Okay. So now we know how to name them. How do we measure angles? Well, we measure things linearly in inches and feet and centimeters and miles. But how do we measure an angle? Okay, we measure angles, what unit? Degrees. And if I had a point and some line on that point, and I would rotate this like that. This rotation about that point, that rotation about that point, the rotation about that point, all of this here is rotated the same amount. So degrees is just the measure of rotation about a fixed point. Okay? And now the next stuff that we're about to do, you're very familiar with. If the measure of an angle is 90 degrees, then it is a right angle. If the measure of an angle is less than 90 degrees, then it is an acute angle. And if the measure of the angle is between 90 and 100, greater than 90, less than 100, then it's an obtuse angle. Okay? This symbol here simply means that this is a right angle and it measures 90 degrees. So that's a notation that we use to indicate right angle. And of course, the measure of a right angle is 90 degrees. Okay? This is angle B here. And as you can see, this is less than 90. This would be 90. That's kind of our point of reference here. It's dashed because it actually doesn't exist. But when we're trying to classify, we think about, oh, this is less than 90, therefore that is called, the measure of angle B is less than 90 degrees. And it's an acute angle. And then here, we're going to use a compound inequality. Here we used an inequality. We're going to use a compound inequality to describe the measure of angle C. And we can see that the measure of angle C is greater than 90 degrees, but less than 180 degrees. Okay. So let's use what we just did here to go ahead and classify these angles. AFB, and I'll give you a second to do this. So AFB would be an acute angle. CFA, since that is there, that means right angle, 90 degrees. This must also be a right angle, right angle. AFD, it's greater than that 90 degrees, so that's obtuse. And CFD, right in here, is acute. Okay. And then in class we'll go over how you use a protractor to measure. We're going to draw a lot of parallels between segments and angles. So we knew that congruent segments were equal in length. Congruent angles are angles that are equal in measure. If these two angles, notice the congruence, this is describing angles, they are congruent. If the angles are congruent, then their measures, that M stands for measure, which is a number, are equal. Shapes are congruent, measures equal. Okay, and the converse is true as well. If two angles have the same measure, then we can call them congruent. Okay? We have the segment addition postulate, which allowed us to add two pieces of a segment to get the whole. And there's a similar postulate for angles. I'm just going to draw a little angle here. Let's call it P, Q, S. Okay? And it says that if R is in the interior, so we have to place some R in the interior. We'll call that R. I'm going to go ahead and draw that. Ray. Okay? So R is in the interior of this angle. And if this is true, then the measure of angle PQR plus the measure of angle RQS equals the measure of angle PQS. So this measure plus this measure equals that measure. Good. And the converse is true as well. And we'll talk about that a little later when we talk about converses. All right, and we had a segment bisector, which went through the midpoint and divided the segment into two equal portions. An angle bisector divides an angle into two congruent angles. Okay,